So yesterday we never got to this example on the back with the oranges. And we're going to I'm going to give you some time to do this together, or do this on your own. I'll run the simulation for us all to use up on the board. But let's read it first and wrap our heads around what's going on. A sample of 50 ripe oranges were taken from a large orchard in order to estimate the mean weight of a ripe orange. The sample mean was 212 grams. In other words, of the 50 oranges that we chose as our sample, the average weight was 212. So sample mean would be X bar. And the standard deviation of our 50 oranges was 34 grams. We are going to run a simulation using the 212 as the population average. So even though it's the sample average of our sample of 50 oranges, we're going to run our simulation as if it's the population average. And we're going to use the 34 as if it is representative of the population, because we have no other numbers to use as the population, right? We're never going to take all the ripe oranges off at one time. We're going to just take a sample of 50, because otherwise we'd probably be dealing with a gazillion oranges, and that's just not practical. So we're going to take our 50, and we're going to assume in our simulation that 212 is the population. And then we're going to get the 90% confidence interval surrounding that 212 that we would be confident that our population average is going to lie between. So running this with how many simulations? It does not say. How many simulations would you like to do? Cole, pick a number. 100. So 212 grams is my population average, 34 is my standard deviation, and 100 is a nice number because your 5th percentile is going to be 5 numbers up, right? And your 95th. And what's our sample size, Jake Clancy? 50. We took a sample of 50 oranges. Good. So run my simulation, okay, and here's the bottom of the list. Remember, there's 100 simulations there. So write down the number that you think is the 5th percentile sample average. Morgan, what'd you pick? 204.9. Okay, raise your hand if you also picked 204.9. Okay. The 5th percentile means you are higher than what percentage? 5%. The 5th percentile means you're higher than 5%. Well, that score is only higher than 1, 2, 3, 4 scores. Right? That's actually the 4th percentile. We need to go to the next one, the 6th score, and I've been doing this when I've been doing it, but I've been doing it quickly, and I was kind of afraid that people weren't picking up on it, so I kind of did this exercise for a reason. This is the 5th percentile number, because it's higher than 1, 2, 3, 4, 5. That's what percentile means, being higher than 5% of the rest. Does that make sense? Okay, so that's going to be our low number, 205.21. Then I'm going to scroll to the top, and I want you to come up with the 95th percentile number. So there's the top of my list. Come up with the 95th percentile number.
second top or the bottom?
This is the very last number on the list, and it's kind of going down. The one nice thing about these simulators is it does organize them from smallest to biggest. Thank God. Because we wouldn't be efficient without it. Hey, Phil, what'd you put? 220.74. Raise your hand if you also picked that. Okay. This is the 100 score. This is the 99, 98, 97, 96, 95. So if that's the 95th score, how many are below it? 94. This is only the 95th number, which means that there's 94 below it. So this is only the 94th percentile. Do we follow? Okay? This is actually the 96th number is your 95th percentile because it is bigger than 95 others out of the 100. Does that make sense? The percentile is not the number of it's not the numbered term. It's this being in the 95th percentile cutoff means that this is bigger than 95% of the data points. And 95 out of 100 fall before that. Okay? A little tricky. I don't know if it's going to get that nitty-gritty on you, but I did want to talk about the percentile a little bit more. So it's 220.8. On a side note, it's impossible to be in the 100th percentile. If you're in the top score, if there's 100 kids that take a test and you have the top score, you're the 99th percentile, right? Because you're higher than 99% of all of the scores. You can't ever be higher than yourself. So you can't be in the 100th percentile. Does that make sense? Okay? So 220.8 used for that one. $220.8. Okay, and so what can we say? What is our conclusive statement? If you're between the 5th and the 95th, what percentage is between there? What's 95 minus 5? That's your middle 90%, right? So we would say there is a 90% chance, or we should probably say we are 90% confident. We are 90% confident that the population average will be between 205.21 and 220.8. Our one sample was 212. Based on our one sample and a simulation of taking 50 oranges a gazillion times, 100 times to be exact, 90% of the time when we took those 50 oranges, the sample average was between 205 and 220. And so we are 90% confident that our population average that we'll never get by collecting all of the oranges in the orchard. It's just not going to happen. This is the best way of coming up with a guess as to what it is. Okay? If you ran the orchard and you wanted something a little more precise than that, if you wanted an actual number to say, our best guess for the population average is such a, and just narrow it down to a single number as opposed to using a 90% confidence interval, here's what you could do, and we've talked about this. We could take a sample of 50, come up with the average weight. We get 212 the first time. We could put all those oranges back and take another sample of 50 and get that average weight, which might be 213 grams. And then put all those back and take another random sample of 50 ripe oranges, and we might get 210. And we could do that 10 times. So take a sample of 50 10 different times, come up with 10 different samples averages, and then average those averages together. And that's really what we did yesterday, the averages of the averages, or the mean of the means, we called it. So we took a bunch of samples, got all the averages of those samples, and then averaged those averages. Do we follow? And that average of the averages gives us a more precise idea. That's what we did. Was that yesterday? Yeah. We took a bunch of samples. We simulated taking samples of these teenagers 500 times. And then the average height of all of our samples, we had the lowest average height was 63. The highest average height was 67.79. But then we averaged all of those means and got 65.05 or 65.35. So we averaged all the averages of our samples, and that number, 65.35, was almost dead on to the population average. So without collecting the entire population, we can take an unlimited number of samples and then average the averages of our sample. Okay? What both C and D tell us is that by using fifth... We already did that. Write the 90% confidence interval right there. You will see the confidence interval kind of written in an inequality format. So from 205.21 to 220.8. We are 90% confident that this will happen. And make sure you know that this symbol means the population average. Population mean, same thing. Okie doke? All right, so with the rest of the time today, just a couple more minutes, I'm going to, everyone's taken their quiz, so I'm going to talk about these quizzes and the 4 questions that were on here. What statement about statistical analysis is false, which means, suggests that 3 of these are true and 1 is false. Okay? Everything can suggest patterns and relationships. Okay? They can suggest that there's a pattern. Nothing really proves that there's a pattern or a relationship. Nothing fully proves it. But everything can suggest it. So experiments can suggest patterns and relationships, and observations can suggest patterns and relationships in data. So 1 and 4 are fine. The difference is what's the cause versus what's the effect. So I just saw an Algebra 1 problem actually where there was a data table with the number of firefighters that were on scene at a fire and the amount of the damage that was done. And as this number of firefighters went up, the amount of the damage also went up. Let's say $5,000, $10,000, $15,000. So we can suggest that there's a relationship between the data. It was pretty clear that as the number of firefighters went up, so did the amount of the damage. So to suggest a pattern and a relationship is fine. But determining cause and effect is much harder. Because right here, when we get this data, we're just observing something, first of all. So this would be like an observational thing. But you can never determine cause and effect with just observing. Because it's not that having more firefighters caused more damage. In fact, you would think the opposite would be true, wouldn't you? The more firefighters, the less damage you would think, because you got more people fighting it. But what's the outside factor here? What is the third factor that's causing both of these to go up? Probably causing both of those to be high. What could you say about a fire that required 9 firefighters versus a fire that only required 1? It's a bigger fire. And so that's your outside factor that is probably causing both of these things to go up. Does that make sense? So just observing, we never can see cause and effect. And the only time we can determine cause and effect is experiments. And I'm not sure we've talked enough about experiments versus observations. We're getting more into experiments, I think, tomorrow. Yes. Tomorrow we'll talk more about experiments. But experiments are when if I'm the experimenter, I control everything. So I assign you 5 people to not get any sleep last night. And I assign you 5 people to get 8 hours of sleep. And then I've assigned you to those groups. And then the very next day, you're all taking the same test. And my study is trying to control everything else, make sure everything else stays the same for both of you, but I've controlled you get no sleep, and you get sleep, and I'm about to give you all the same tests. And my hypothesis is that getting more sleep will help you do better. And only if I control it myself, and I randomly assign people to those groups, now I can be a little bit more confident of cause and effect. So that would be 2 is true. So experiments and observational studies, anything can suggest a pattern, and experiments are the only thing that could determine cause and effect for the most part. But observational studies do not determine cause and effect. Okay? You can't decide if that was necessarily the cause. Okay? There's a classic example about kids that graduate in the top 10% of their class and their mother's level of education. Now, just because people's moms went to college doesn't necessarily mean that you're going to be in the top 10%, but there's a very strong correlation there. But is it the fact that the mom went to college that is making the kid do well in school? No. It's probably the fact that the mom went to college and therefore is maybe on the kid a little bit more to do their work, and there's just so many other domino effects in between. And so it's an observational thing. It's not the cause and effect, but it's just a correlation without being cause and effect. Okay, number 2 gave us a mean, modal, and standard deviation. The mean was 496. The mode was 430. We do nothing with the mode in statistics at this level. And the standard deviation was 115. So when they want the 95% interval, that's 2 standard deviations away from the average. So your average was 496 plus or minus 2 standard deviations, and 2 standard deviations was 2 times 115. So that's 230. 496 plus or minus 230 gives us the 95% interval. Okay, our speeds on an interstate, we've got our mean speed and our standard deviation. What percent of the drivers are traveling between 70 and 80? Guess what? This is your norm CDS. Minimum of 70, maximum of 80, mean of 72, and standard deviation of 3.2. Is the bell going to ring, or do I have 1 more minute? Okay. I'm going to hand back these quizzes, and your homework for tonight is just corrections on them. So once you get this, there you go.
for the number one, I don't remember it.
There's a video online you can go back and re-read, or re-listen to.